Good afternoon, everyone. Welcome, and thank you for attending this HRE4 Europe webinar. My name is John Kapetanakis, and I'm a member of the HRE4 Europe team at Aalborg University in Denmark. We are hosting a series of webinars about the HRE4 Europe project funded by the European Commission. This is the second out of 8 webinars scheduled for this autumn, and 9th in total for 2018. At these webinars, we dive deeper into the latest results of the project, that is the heating and cooling strategies, also known as roadmaps. Today, Susana Paardekooper, PhD fellow at Aalborg University and member of the modeling team of HRE4 Europe, will present the main features of the heating and cooling strategies for the European Union countries where the gas sector holds a considerable part in the energy system. If you have any questions or comments relating to the presentation, please use this relevant box in the sidebar on the right of your screen to send to us. We'll have some time to address these before the end of the session. Susana, over to you.
Thank you. I'd like to join John in thanking you for being here and welcoming you to the webinar. As you said, my name is Susana Paardekooper, and I'll start by briefly introducing the project in general, and then we'll move into some more specific results for the countries where currently the heating and cooling sector is gas dominated. We'll dive into a few countries and then show the results for those as well, and then point you to some resources that can help you further that we have available on the website and in the different social media channels that we have as well. So to start with, this is the overall purpose that we have in HRE4 Europe. This has been a 3-year project, and the aim is very much to create scientific evidence in the form of data, in the forms of tools, and in the forms of methodologies to be able to support long-term planning for heating and cooling within the context of a decarbonization scenario and a decarbonization future. By quantifying a lot of these impacts and building scenarios on the different ways in which these can be done, we'd like to contribute to the planning strategies and the different policies that can move towards achieving those futures, but also make a more transparent and inclusive conversation using the data that we can create. So this is not something that we built overnight. This series of projects started in 2012, which was when the European Commission brought out an energy roadmap for 2050. And within that, there was very little mention of heating and cooling in general. And from a Scandinavian perspective, there was no explicit attention towards district heating. So the project started from the base of looking at if district heating had some kind of future within a decarbonized future scenario or within a decarbonized energy system. And from there, through the years, we moved towards a more holistic approach where we look at the entire heating and cooling sector in urban areas, in rural areas, in the residential sector, but also in different types of industry, and specifically how that connects with the energy system at large, so with the electricity sectors and also with regard to the transport and other industry sectors. So this is the group of people that we've been working with. The consortium has 14 partners and 10 advisory board members. We're about 40 people in total, and we worked on this for 2.5 years. So as you can imagine, we have a pretty substantial amount of data, tools, methodologies, and everything set out. And we've made those as available as possible on the website, but also through this webinar series by showing some of the results and hoping that you can then use those to start looking more specifically at your country or your area or your planning area relevance. So one of the main things that we start looking at when we start taking the heating and cooling sector from where it stands now towards 2050 is the kind of obvious observation, but still something that needs to be said repeatedly, that heating and cooling is a very large part of the energy system. One of the first things that happened within the context of the project was to dissect the heating and cooling sector as it stands today. And from that, we learned that it's the largest energy sector that we have. It's larger than electricity and it's larger than transport. And if you combine it for the EU, it represents basically half of the final energy demand. A large part of that is space heating. If you look at the graph, the bar graph at the top middle left of your screen, then you can see the proportion between space heating and cooling in buildings in Europe. And there's only really 4 countries where cooling plays a particularly large part, which are Cyprus, Greece, and Malta, basically the Mediterranean island nations. In the other countries, even in the southern parts of Europe, we see that heating has a significant role to play, but also that space heating continues to have a significant role to play. So this is a European-wide problem. When we talk about heating and when we talk about cooling, these are not regionally bound issues. These are issues that are common across the entire European Union, and therefore issues that need addressing within the decarbonization of the energy system throughout the European Union. We've worked towards that, and through different models and different methodologies, we've created these roadmaps for 14 of the European countries, and those represent about 90% of the heating demand and 85% of the cooling demand. The main conclusion that we've really come out of that is that it is possible to decarbonize the European energy system with particular regard to the heating and cooling sector in line with the Paris Agreement. We do this using only technologies that are currently known, that are currently available, and that are used in different parts of Europe at the moment. So this is a generally optimistic message, especially in light of the ICC report in the last few days and weeks. This is an important finding. It's possible. We're not completely lost, and there are options available to decarbonize the heating and cooling sector. These options have a similar cost to other decarbonization factors and are more efficient than can bring a high level of efficiency depending on how you achieve that. In terms of the heat roadmaps, there are 3 basic pillars of the scenarios that we've developed. Because heating is local, those differ for urban areas and for rural areas. What we recommend everywhere is a deep level of energy savings in the built environment, but also in industrial processes. We'll talk a little bit more specifically about that later, but overall, we see that we're somewhere between 30% less than today in terms of space heating, which is a high reduction compared to what is currently within the policy and what has happened in the past, but is something which is in line with most recommendations towards the decarbonization of the heating and cooling sector. For urban areas specifically, and that becomes important today, we start looking at district energy networks, specifically district heating and cooling, as ways to both have efficiency in terms of being able to use energy that is otherwise not used, and in order to be able to integrate renewables. In rural areas, we look at heat pumps as a way of electrification, which both builds a very nice link with the electricity sector, which also requires a high level of decarbonization. And in that link, we find that there are synergies that can aid on both sides, the heating and the cooling side, but also on the electric side. So from these principles, we built heat roadmaps for the 14 countries that we address in the project. And because heating and cooling is local, they are very different in terms of the exact numbers, but these general trends in terms of this approach work very well. And it's based on the idea that we're looking for efficiency, both on the demand side, both in the built environment and in the processes that require heat, but also on the supply side through the provision of efficient district energy and through heat pumps, which can convert at a very high rate. So to bring that into some more detail, we'll talk today mostly about what we've broadly called the gas-dominated countries. When we talk about the current usage of gas for space heating, there's a wide range in Europe today. There are countries where there is no gas being used in space heating, and the highest level is in the Netherlands, where almost 85% of the space heat is derived from gas, and particularly from gas boilers. So we'll focus today mostly on the Netherlands and the United Kingdom, because these are the areas where the gas use is the highest for heating. On the other hand, this image shows it to you aggregated on a national level, but of course there are different regions. If we look at parts of Italy and we look at parts of France, then there are urban areas where gas usage is very high, but on a national level, it doesn't reach the same efficiency. So from a local perspective, it may differ very much in different areas. Some of the other countries where we see gas usage and where we see gas usage rising is in Eastern Europe. There's a specific webinar dedicated to some of these countries, but it's a good thing to keep in mind as we move towards new types of infrastructures and infrastructure development for decarbonization. So based on these, let's talk a little bit about gas for heating. There are some obvious examples, especially in the Netherlands and the UK, where the infrastructure is very much already in place, which also means that there have been long-term investments that have been made in order to put those gas grids down and enable them to be there. These are long-term investments, and from a transition perspective, it makes sense to keep using these. Once you have the pipes, then the pipes are available. On the other hand, we're looking towards 2050, so this is not necessarily something that we look at specifically here. The other thing that we see when we start looking at these gas-dominated countries is that there's a lot of institutional and planning frameworks that are established and have been developed, and that's been because there's been decades of development of gas-based heating and cooling. And that's something that when we, put things into simulation models and start looking at how to transition things, need to be considered. It's not just because we put it into the model that things magically happen. So that's something that we have to take into account and that we have to look at very specifically as we move towards 2050 and move towards transitions of decarbonization. The third thing to consider, and this comes back a little bit to the conversations we were having about Eastern Europe, and which we'll touch upon later, is that in some ways gas boilers can be a comparatively efficient way of providing heat. They're much better than oil and coal boilers. But also there are old and inefficient district heating systems which are based on these more heavy fossil fuels and don't use a lot of renewable or excess heat, in which case the carbon intensity can be higher than what happens in what happens in gas infrastructures and gas boiler usage within buildings. The third thing is that when electricity is used, it depends very much what the carbon intensity of that is on the carbon intensity of the electricity. To the right, you see the map from this morning from the electricity map. It shows basically the carbon intensity for all the electric regions. And that has a very high driver of what the carbon intensity of electric heating is. And in some cases, you can find that gas heating can be less carbon intense than that. So there's a good reason that gas is used in many countries, and there's a good reason that it's being considered as we move towards decarbonization. But at the same time, it's not something that in the heat roadmaps we use a lot, because there are some issues as we move towards deep decarbonization scenarios. The first is the obvious, that deep decarbonization requires us to get rid of fossil fuels to the largest extent possible, and gas is a fossil fuel in its natural gas form. As we look specifically at the Netherlands, this is maybe not so much of an issue for other gas-nominated countries. There are extraction issues, and that's been a large part of the driver in some local cases to start looking at alternatives and start looking at different ways of providing heat. There's a large geopolitical incentive here, which rises every now and then. But in 2016, we imported 70% of the natural gas in Europe. And as we look towards the ambitions of the Energy Union, and as we look towards the more strategic energy planning ambitions that we have looking towards 2050, then that's not necessarily something that is in line with those, especially since there's a relatively high cost to that. That is also then leaving the European Union and could be used in other ways if we manage to keep it within the areas. When we look at where gas could be used, and especially as we start talking about alternatives to natural gas, but in gas form, then it's important to have a consideration for the entire energy sector. What we see is that gas in deeply decarbonized scenarios becomes increasingly valuable. There are a lot of industrial processes where gas is necessary. There are not as many alternatives available as there would be for the heating and cooling sector, and where it's more difficult to find substitutes, or it's more difficult to find technical alternatives that are possible. When we look at heavy transport particularly, this is also the case, and gas in non-natural gas can play a particularly large role there. But the other issue that we find as we do energy simulations is that it requires a large amount of power capacity to be able to produce that energy. When we're looking at hydrogen production and electrolysis for these kind of transport options, that starts playing a role, and that's something that has to be considered as we look for a sustainable heating and cooling sector within the context of also sustainable and decarbonized energy sector as a whole, including the power sector. So we have to find a solution for the heating and cooling sector while trying to avoid the use of gas as much as possible. This isn't necessarily a problem because there are a lot of other options for heating. For starters, if we look at the amount of energy that we lose in power conversion processes in Europe, then there's a lot of excess heat which is currently being wasted. I hope that the graph to the right will look familiar to some people, but if not, it basically shows you the amount of energy that is available if we compare primary energy to final energy and then end use. And those amounts of energy that are being wasted in power plants and in industry are similar to the amounts of energy that are being demanded in buildings today, particularly the amount of heat that's being used both in buildings and in industry. So there's an inefficiency on the one hand, but on the other hand, that's something that we can use as we move towards more sustainable and efficient solutions. So these are the kind of considerations that we have towards gas and towards gas-based systems as we start looking at heat roadmaps for these gas-dominated countries. To give a bit of the background on the methodology that we've used, we use 4 different types of energy models. And the reason we do that is so that we can combine very specific knowledge on the built environment, which is a fundamental part of the heating and cooling sector, in the sense that that is where a large part of the demands take place. For industry, similarly, heat for industry can be very varied, both in temperature, in terms of what the use is, and also in terms of temporality. So we have a relatively detailed description and profile of what the different types of energy demands are for heating and cooling. This is available also as one of the outputs of our project, and can be the whole data set is available and can be downloaded. The second element that we include is a spatial disaggregation of the different heating and cooling demands. Because heating is so local, and because it's something which is particularly infrastructure heavy, it's important to be able to look at where the energy demands are and where the resources for heating and cooling are, and to really be able to look at those on a granular level within regions, within cities, and within areas, to be able to make those links between the two. This is especially the case when we start looking at different types of renewable energies and excess sources for district heating. So through the PETA map, the Pan-European Thermal Atlas, we have a hectare level disaggregation of the heating demands and also some local identification of where excess heat sources are and where renewable sources like geothermal and solar thermal might be. Again, this is available online. There's a link at the end of it. Then to be able to combine these into energy system models, we've used both the JRC EU Times model, which is an evolutionary model in the sense that it's possible there to move between the different years and look at what happens in 2015 and how that evolves over time towards 2050. We've also used the energy plan model, which is an hourly simulation-based model, so that we can look really specifically within each year what happens in every hour. Especially as we start looking at really highly renewable systems and very deeply decarbonized systems, that becomes important because a lot of the resources that we see there, wind, solar, but also, again, different types of geothermal energy, vary on an hourly level. So to be able to make those connections for every hour in the year, we need to be able to simulate them every hour. Those different things are combined. We've created some baselines and some scenarios that we can compare the heat roadmaps to. And through that, we've created these heat roadmap Europe alternatives. So this is how we've approached it from a methodological point of view. Based on this, as I mentioned, we've made these 14 heat roadmaps, and we'll discuss a little bit today about the main ones where we talk about really the gas-dominated areas. So to break it down back into those 3 pillars that we discussed earlier about the energy savings, the heating, the supply options in the urban areas and the supply options in the rural areas. For the energy savings, we can see that there's a serious reduction in heat demands, particularly within space heating demands. I've put them here for the Netherlands and for the UK, but even under the current policy initiatives, which you see in the middle bar, there's a significant decrease in the space heating, particularly as we move towards 2050, if you compare it to the 2015 level on the left. This is not so much the case for cooling. Cooling expands in most cases, also even in these kind of Northern European, Central European areas. And we see that process heat is something which is very difficult to address in terms of really making hard energy demand savings. When we look towards the heat roadmaps, then you can see that there is a decrease, particularly in the space heating, but also in the process heating. But it is not possible to completely basically make the energy demands disappear. Savings alone and energy efficiency on the demand side alone will not be able to decarbonize the heating and cooling sector, simply because it's not possible to completely eliminate these kind of demands. So there also needs to be a solution towards being able to supply this heat. Now, because space heating is such a relevant part of this, and because this is where really the most savings are made as we talk about refurbishing buildings and building high energy performance new buildings, we've broken this down further. I've got them here for the Netherlands and the UK, but also some other countries where we have a high level of gas. And if we compare that to, again, the current policy as it's projected to be towards 2050 in the form of the red bar, and what we recommend in the Heat Roadmap Europe scenarios in the blue bar, then there does need to be a focus also both on the ambitions of the heat savings that we make in space heating, but also on the implementation of these savings. What stands out particularly for gas countries is that compared to the other countries that we've analyzed in this project, there's a relatively lower level of ambitions for the energy savings. In some countries, that's because there have already been a lot of efforts. So the current policy recognizes that a lot of this happened in previous years, and savings, the easy to make savings have already been made. But at the same time, the ambitions need to rise in a lot of cases. For the Netherlands, you can see that the current policy projections are that there would be about a 20% level of savings, but really, from a socioeconomic perspective, we're looking at something which lies above a 30% level of savings if you compare the space heating demand from today to what we're looking at in these future scenarios. In terms of how to achieve that, that basically means higher refurbishment rates, so more houses and buildings being refurbished every year, and a deeper level of renovation and refurbishment when that does happen. But this is something that underpins a lot of the energy savings that we find because space heating is so dominant in a lot of the energy systems and the heating and cooling systems that we see. So this is the first step when we look specifically at gas dominated countries and the scenarios that we've built in these heat roadmaps for the gas dominated countries. The second element is then how to supply that remaining heat. And for that, in the rural areas, we find that district heating is mostly the solution which can provide the most efficiency at the best cost. And in rural areas, we look mostly towards heat pumps, again, because they have a very nice connection with the electricity sector that helps further decarbonization, but also because they can very efficiently use renewable energy that is being produced there. So overall, for the Heat Roadmap Europe 14, we find a level that approaches half. You should be looking for the little green triangle, which sits within an interval where the costs don't change significantly. So they change about 0.5%. So that range is really what we're looking at to be able to decarbonize in an efficient and socioeconomically feasible way. We break that down specifically for these gas-dominated countries, and we can see that there are a lot of differences. In the Netherlands, we're looking at over 50%. Italy is one of the highest ones that we see throughout the Heat Roadmap Europe 14 countries, at approaching 70%. For Hungary, we see that it approaches 20%, which is actually more than is currently in place there. And then for the UK and Belgium, we're looking at somewhere between 30 and 40%. Now, these figures are much higher than is currently the case. If we look at the whole of Europe, then the level of market share for district heating traditionally has been around this kind of 10-12%. In some countries it expands, in some countries it decreases. But there's a significant shift that needs to be made if we're going to reach these levels. In most countries, that is also the case. In the Netherlands and in the UK, there's been a lot of expansion of district heating in the last few years, and there's been a lot of attention for this. But the current levels are very low, and the current levels do not approach what is modeled and what's recommended within the Heat Roadmap Europe scenarios. The same goes for Belgium and Italy, and in Hungary, we have the situation where there is, compared to the others, a relatively high level of district heating, but this really is in need of refurbishment and renovation to be able to bring it towards the kind of district heating that we're looking at within a decarbonized energy system in 2050. To explain where these numbers come from, within the combination of all these different models and the energy system analysis that has been done, the main driver of these is the spatial location and the spatial density of where the demands are. So at the bottom left, you can see an example of that for the Netherlands, for the curves that basically represent the cost of distribution within the district heating system. So they don't include the supply, but they do include what the infrastructure costs of building the pipes would be. And that's done by looking at the spatial models and making an allocation model for how these would be able to connect to provide these systems. Again, we have these available for all the countries, and they're in the reports for both country roadmaps, but also in a specific report which explains the methodology behind them. When we look at the remainder of the market share, so that which is not district heating, then we are looking mostly at heat pumps. So we're looking mostly at electrification. Again, this is a significant change from what happens currently. There's about a 1% supply by heat pumps when we look at residential heating at the moment, and that really needs to expand. So there really needs to be a change in that. And because heat pumps are a form of electrification, there's also an infrastructure implication there when we think about the electricity grids. So these are the general ways in which we foresee the heat being supplied when it is no longer supplied by gas and as it is no longer supplied by gas. I think it shows well both how heating is based on a local analysis and how that local element of heating is necessary, but also how the energy system analysis comes into place as we start looking at electrification. This is an example of that, but also to show you the maps that were used to be able to kind of create these cost curves and look at these different linkages. We call them the heat synergy regions just because it explains very well this idea that there are, on the one hand, large amounts of energy being wasted and large amounts of energy that are lost in conversion processes and not recovered. And on the other hand, very dense areas of heat demand where these could be used in infrastructures like district energy. On the left, you see the example of Rotterdam, which is a good one in terms of showing both sources of excess energy from power production. Those are not necessarily things which will continue in the future in that exact location, but do provide a good starting point also for where power plants are strategically placed. But also different types of industry. Rotterdam has a lot of chemical industry, there's a lot of petro industry. As we move towards more decarbonized energy systems, then we also start to see fuel production as being one of the sources of excess heat. So we can geographically locate where the current industries exist and be able to match them to the areas where the demand exists. On the right, you have Middlesbrough in the UK, which is, again, an area where the amount of energy that's wasted exceeds the amount of energy being demanded in that area by more than a factor of 2. For the UK, there's about 80 of these regions. In the Netherlands, we're looking at about 10 of them. And again, these are available, you can have a look at them. But I think they really nicely show this idea that there is, on the one hand, an amount of excess heat available, and on the other hand, demands which are currently being met by gas, which is, as explained, problematic, but could be provided in different ways. When we look at the heat roadmap scenarios and the way that we envision supplying the district heating in that, one of the main differences compared to how district heating is supplied today is that we see a much larger variety of sources. So there is still a lot of energy coming from cogeneration, the combined production of heat and power. This is mostly due to the demands of the electricity sector. So this isn't necessarily the production of heat because the district heating system needs it, but really the true recovery of heat as it is being used in power production. And the idea that it's an excess product of the electricity production, which is still necessary. It's mostly based on biomass. In the UK, there's also some gas still in the CHP plants, but this is again more driven by the needs of the power sector than necessarily by that of the heating sector. We see higher shares of heat pumps. If we combine the heat pumps in the individual provision of heat and within the district heating system, then it's the majority of heat. The main way in which we supply heat then becomes through heat pumps, although they're not all in an individual application, but many are also within this district energy application. And between the heat pumps and the combined heat and power, there's a really nice interplay with the power sector, which really starts to form a fundamental part of how we then decarbonize not just the heating and cooling sector, but the energy system at large. The other sources that we see are, again, the recovery from industrial excess, including in the future also different types of fuel production, and a higher share of renewables. For geothermal, there's a minimum potential of about 6% for the Netherlands, but there's also some solar thermal in there. This allocation and this simulation of how we supply this district heat is mostly based on geographical demands. So we also see that if there's an industrial plant which is not geographically located near any type of heat demand, then it's not possible to recover that heat. And this then links these shares, but also the planning processes that should be behind this as we move towards this transition to the spatial nature of the heating and the way that we use the local geographies of the area, not only on the supply demand side, but also on the supply side. So combining these, rough findings of it, to put it shortly, is that it is possible to decarbonize in an affordable way. We find that it's about 6% cheaper than if we compare it to a conventional decarbonization. It's very strong to say that it's much cheaper, because when we project towards the future like that, 6% is not enough to really be sure to say that it will be cheaper and that it is fundamentally cheaper. But it does provide strong evidence that it will be within the same realm of cost, and that it's a viable alternative and something that has to be considered. When we look at the energy efficiency of it, then there's about a 10% reduction in primary energy. And as we said, this becomes very important as we also look at the power sector and also look at the transport sector. The idea is to decarbonize not just the heating and cooling sector, but decarbonize it in a way that facilitates a decarbonization of the entire energy system. So that's really an effect of being able to use a lot of these sources of heat that are otherwise being wasted or otherwise unavailable, and at the same time also have these heat pumps provide a very efficient way of producing heating and cooling using the resources to their maximum. If we compare it to other different types of scenarios, particularly this baseline that we created and also a conventionally decarbonized system, then there's a reduced peak on the electricity, a reduced pressure on the electricity sector as we move away from full decarbonization, full electrification. It's a lot of shins here. But we see that the heat roadmap that we've designed here and that we simulate here, using the amount of district energy in it that we use, decreases the pressure on the electricity sector compared to a full electrification scenario. And that's an important finding, because it really shows that there's a strategic necessity to look at the types of infrastructure that we're developing. By having 50% of the heating and cooling demand through district energy, we can also help the electricity sector decarbonize in a more efficient and in hopefully a faster way. So this is expressed all in the right diagram. It's basically a comparison between what we have in 2015 and the Heat Roadmap Europe scenario as it stands. You can see the large blue circle becoming smaller, basically because the primary energy supply necessary to be able to fulfill the demands is less. There's a larger share for district heating, again, in a very different way as it works today, because we have a much higher share of variable renewables and we have a much higher share of excess heat recovery. And then this comes through in the electricity sector, which you see in the three colors encompassing the district heating supply. There's a much higher level of variable electricity in it, both in terms of wind, but also in terms of solar. And then there's a the amount of electricity that's produced via power plants and CHPs reduces. However, when we look at the heating and cooling sector again, this means that there's a lot of change that's necessary. The graph here shows the final energy demands, which is the way that the targets are being set, or the way that targets have been measured from 1990 through to 2015, but the way that the target has been set for 2030. And even though we've spent a lot of effort in the past trying to reduce this amount, it's not necessarily sunk by a lot. There's a bit of an increase in 2005, and then in 2015, we see that we're basically at the same level as 1990. The growth has halted, but at the same time, it's not really fair to say that we've seen a massive decrease in the energy demanded for heating and cooling. However, as we look towards 2030 and we look towards 2050, that really is necessary. So the trend of being able to halt the growth, but not necessarily see a reduction, needs to change. It is necessary to see a decrease in the amount of final energy that's being used. As we look towards the Heat Roadmap Europe scenario, a lot of that final energy reduction comes through the use of these heat pumps in the rural areas, but there's also really a necessity to be able to recover heat and use heat efficiently within the district energy systems. We look at the renewable shares of this final energy, then there's a growth that's visible both from the past but also towards the future. And the idea is that if we can put the infrastructure and the elements into place that can enable this growth in renewable shares, that those will follow, because we need to start using those renewables on the one hand in the electricity sector, but also in terms of supplying the district heating infrastructure with energy that is low carbon and decarbonized and sustainable. So there's a general optimistic message that it's possible. On the other hand, there need to be changes, and these changes come mostly in the form of putting in new infrastructures. And when we look at the gas-dominated countries, that specifically comes in the case of replacing a lot of gas infrastructures with district energy infrastructures. When we take it away from the general findings and the heat roadmaps in terms of the energy simulations, the discussion that needs to take place about these transitions is basically that this is not an easy task. This is not a trivial thing to do. Heating is a European-wide problem, but at the same time, it is also something which is very local, both in terms of how it's organized from a technical perspective, but also in the terms of how it's organized from a cultural and an institutional perspective. There's a lot of long-term planning that needs to take place in this, both in terms of the gas infrastructures that already exist, but also in terms of the district energy infrastructures and the electricity infrastructures that are necessary in order to be able to make this transition. And when we talk about the way that these infrastructures are organized, then we're also talking at a local level about how the cultural models work towards the acceptance of decarbonized energy in its very different forms, particularly when we're talking about waste heat or excess heat, but also in the different ownership models that we have and the different ways in which profits are distributed. For infrastructures, that's always an issue, but especially as we're transitioning from one type of infrastructure to another, those are things that need to be discussed and solutions that need to be found, and market models that need to be created within the context of these local conditions and local assumptions. So hopefully that's also something that we can have the discussion about and talk a little bit about during the remainder of the webinar. Before we move to that, I just wanted to kind of point out the resources that we have. As I mentioned, we have these 14 specific country heat roadmaps. Those exist for all the countries which are plotted in red. And then we have a main report which summarizes those all together and talks about the European-wide trends, but is also maybe relevant for those countries which aren't put together. We have the Pan-European Thermal Atlas online, so you can go and have a look at this really kind of linking of the local resources versus the local demand, again, for all these countries. And then we have the demand profiles available, which, especially for the gas countries and especially within the context of looking at what kind of future roles gas can play, are interesting because it breaks it down not just by what the energy carriers are, but also where the energy is being used and where the energy carriers are used, including the industrial sector, which makes it really interesting to look at and see what the totals are and how those the relative numbers count up together. We have a specific document on market uptake approaches, including an outlining of barriers and case studies as we look towards implementing these different kinds of infrastructures to decarbonize the heating and cooling sector. And then A blast from the past, we have a YouTube video about natural gas versus district heating in urban areas. It's a few years old now, and it doesn't include these latest results. It's based on the Heat Roadmap Europe 3 iteration and the results that were there. But conceptually, it's interesting to have a look and see in some more detail to really discuss these networks and these infrastructures and the way that they compare up together as we look towards a low carbon and decarbonized energy future along the lines of the Paris Agreement. So based on that, I think that it'd be nice to move towards the questions and towards a discussion on these issues, particularly within the gas-dominated countries. Thank you very much.
Thank you, Susana, for your really nice presentation. We have indeed received some really interesting questions, and I hope we and you can address in a very way that we can give the answers. So let's start with the question about the infrastructure, and where Kriya Juvet is asking if the existing gas infrastructure can be reused and how, and in what places would it be particularly interesting to reuse it, like for example with synthetic gas.
Oh, I wish I had the one and ultimate and final and answer to that for everywhere. I think this is something which, especially in this gas countries, is still very much being explored. On the one hand, it doesn't really make sense to have the gas infrastructure that we have today. And we talk a lot about reusing it, but at the same time, it's necessary to understand that we're looking towards 2050. And, you know, in climate terms, that's tomorrow. But at the same time, that also means that a lot of that will naturally retire. So it's not like we have to, you know, dig it all up tomorrow and then never get rid of it. It's really about enabling a transition away from those gas grids towards something else. In terms of how they can be used, that becomes very much a local issue. The gas that we see remaining in the heat roadmap scenarios and the way that we've modeled them, including the syngas, is very dependent on the different types of industry that are available and the different types of transport that are available. Particularly when we look at hydrogen and hydrogen storage and those kind of things, then the main thing is that it's very important to spatially locate those near the productions where, or near the areas where that hydrogen is being produced. So it's not really necessary to say from the research that we've done, you know, in this stretch of gas, keep it, in that stretch, rid of it. But in terms of the role of the gas grid should be, I think it's very much within that realm. How do we use the gas grid to support the industries that need the gas? And how do we use the gas grid to facilitate the production of this hydrogen, of syngas? Also, when we talk about methane and where methane is being produced and where it's then being used, that's what we should look at the gas grid for. And those are things which are very much still developing. But I think it's clear that the gas that is going to be used in the future, because I don't think that anyone disputes that there is going to be some type of green gas within a decarbonized energy system, the gas grid should fit the needs of that. And those are not necessarily in the heating and cooling sector. So that spatially determines already for a large part where that gas grid should go.
Yeah, and talking about this transition, where to start first, like when and how to shift from natural gas towards district heating and electrification, like which one of the two should come first? So is this also part of this exploration process, I guess?
It's not something that we've looked at specifically within the Heat Roadmap Europe project.
Yeah,
so
yeah, sure.
The modeling that we've done is very much towards 2050 in the sense of what should it look like as the primary question, and then how do we get there as a secondary follow-up question. I don't think that we have I don't know how to say this, privilege to be able to say that we should do one first and then deal with the other one next, especially because these are all long-term investments. If someone is renovating their roof now, then they probably won't be doing it for the next 40 years. So if that renovation is not done at a very high standard now, then it will not be renovated at a high standard by 2050. And similarly, you know, if we do put down infrastructure now, then it is likely to still be there in 2050. So we have to be sure that it's in many ways robust and resilient to what the needs are then. So I don't think it's a step 1, step 2, step 3. I think it's more something that needs to develop on in all areas.
Now I have to move to the heat pumps. You mentioned the large heat pumps, and I would like to comment, as Seth Gross is asking, how large these heat pumps are considered in these future scenarios, and where's the low side of the heat pump effectivity, which is what are the lowest temperatures these heat pumps can operate. I think these questions like a bit more technical, but have been any considerations regarding these limitations in the technology?
Yeah, a lot.
Yeah.
I mention heat pumps a lot because I think that they're really nice. I mean, they really exemplify this link between the heating and cooling sector and the electricity sector and the way that they can help each other. When we talk about heat pumps at an individual scale, then you're really kind of looking at these, 5-10 kilowatt standards. So basically as a direct substitution of a boiler that you would have in your house, or of a heat exchanger that you would have in your house. So the individual heat pumps are really at that building level. When we talk about the large heat pumps, then we're really talking about kind of 5 megawatt ones. The technology that exists today, typically, even if the installation has, 20 megawatts or something, then they'll be built in units of 5 megawatts. So that's basically what we've worked with. In terms of their efficiency, this is one of the more one of the things where there's a bit of a range in terms of what people expect of the future. We've been very conservative in the COP assumptions. So at an individual level, we're talking about something like 3.5 on average over the year. And for the larger ones, we're looking at about 4.5, in some cases 5. These COPs are very dependent on what is being used for the heat accumulation, what would take the heat out of. Things that we haven't considered in this project are, for example, using heat pumps to recover what they call unconventional excess heat sources. So we're seeing some pilot projects, but also some market projects of being able to use heat pumps to take the excess heat out of data centers, being able to use heat pumps to take the excess heat out of supermarkets or out of metro systems. And that is not something that we've included here because we want to be conservative in the assumptions. That having been said, of course, if that does turn out to be possible, then you're going to see an improved coefficient of performance, and that means less pressure on the electricity sector and a less high requirement of capacity for these heat pumps. You need less capacity to be able to improve, to be able to provide the same amount of heat. So that's not something that we've taken into account, but it's something which could be possible.
Yeah, so I have a question now from Robert Honeman. Do you agree that the heat pumps may not operate effectively in less energy efficient and older properties? And is this a challenge to deploying only heat pumps in rural areas? And what would be the biogas role there?
I'll take it in 2 parts, basically. It's not so much that the heat pump is less efficient. I mean, the heat pump is the heat pump. It's more that at that point, the heat pump is not fulfilling the demands of the people who are living in the home or who are living in the building, which in a way is really, the end game is not to convert energy. The end game is to fulfill people's demands. That goes hand in hand with the need for renovation and the need for better energy performance of buildings. And I don't think that goes specifically for heat pumps. I think that we see that all across the range. We see that no matter where we look. Rural areas are, in some ways, I mean, we talk a lot about cities, and cities are a bit of the buzzword for decarbonisation and energy efficiency at the moment. But rural areas present their own challenges because typically people have larger homes, so there's more floor area to deal with. And traditionally, rural people have had a higher cost of energy also because of these building issues. So that's something that needs a lot of addressing. Now, if we look at the Netherlands, the rural areas in the Netherlands are a little bit different from, the rural areas in the south of France or the rural areas in the center of Spain. So there's a conversation there to be had. I mean, in the Netherlands, we've hooked 99% of the country up to the gas grid. So there's a context for rural in the Netherlands, and there's a context for rural within Europe. The conversation that's happening about using gas in these rural areas is not something that we've looked in this project. As I said, it's been 3 years. We're not that fast. But what I would expect and what I would hypothesize to be the case is that in that case, you're keeping the most expensive part of the gas grid. So you're keeping really the peripheral areas. And those are not the areas with the highest returns. I mean, the lowest hanging fruits and the places where any type of infrastructure is most efficient is where people live densely together. So that element exists. And then the second element is that even if you've got a very inefficient heat pump, then basically instead of being a heat pump, you have electric heating. So the trade-off then becomes, is it better to keep the gas grid and use this really scarce gas there, or is it better to have direct electric heating? As I said, this is not something which we've investigated because we set the whole thing up 3 years ago, and 3 years ago the conversation was a little bit different. But that's where it becomes interesting, because in the models that we have, we can really look at the hourly value. So we can look at, they call them the peak winter areas.
Susana, sorry, the sound was lost. Can you face the microphone again, and we just lost your last sentence.
Well, as I said, we haven't done it. We didn't include it in the research design because of the models that we've developed and the tools that we've developed. It would be possible to do it, and it becomes very interesting to look at kind of hours in the winter where there's a very high heat demand, but there's not a lot of wind. There's a fair amount of sun, and then to see kind of what the trade-off is between using electric heating and providing peak capacity at that point versus, on the other hand, providing it via gas. In both cases, reducing the pressure on the electricity grid by having district energy in the cities is going to help, because it will, no matter which you go for, reduce that peak demand. So it's an interesting question, but I don't have an answer for you. I'm sorry.
Yes, thank you. The previous question had some biogas there, and there are 2 questions from Sam Foster and Martin Hayek about this. First one, if I'm not wrong, the biomass is taken into account or not in the case of Netherlands?
Yes,
because
it is.
It is. So because those two questions, we have that there's an infrastructure to deliver gas, so biogas, bio, SNG, and hydrogen could be options. What is the considerations in this project about this?
Well, there's 2 approaches towards it. The infrastructure is there, but when we look at the cost of those things, the infrastructure is not the costly part. Setting up these hydrogen production plants, then setting up the facilities to be able to turn it into some kind of upgraded gas, because you can't use hydrogen directly in the gas grid. It needs to be mixed with something else. And then for a lot of industrial and transport applications, to turn it into some kind of syn fuel, those are the costly parts of it. So those are also points of focus in terms of how we can use these types of energy. And again, when we look at the whole energy system, then the chances of using that very valuable energy in the heating and cooling sector, even though we have the infrastructure, it's the likelihood of them being being prioritized for the industry, which also needs to decarbonize and which faces large challenges in that, and the transport sector, which in some cases can electrify, but in some cases also cannot, are a lot higher. So in a world of scarce, let's call them green gases, it doesn't seem likely that heating and cooling would have the priority there, even though the infrastructure currently exists. Just because to provide those amounts of biogas or of gas wouldn't just would make the whole thing extremely expensive, rather than using other options for heating that exist and that are technically feasible.
Yeah, and some questions about the spatial aspects and the district heating. I have one question from Glenn Sustas that says, what will be the expectations on the size of district heating systems, like many small or just a few of large networks? Is there like a preference, or is always like a case consideration in this kind of question?
You can go onto the thermal atlas and you can have a look at, there's a layer, I can't show you, but there's a layer which shows you the extent of the district heating network at different market share rates, if that makes sense.
Yeah.
So you can explore it for yourself. In most cases for cities and conurbations, you're looking at what, especially in countries where district heating is not established, would be considered large district heating systems.
Yeah.
You know, there's really a coverage of the entire city. At the same time, there's also a lot of potential for areas which are kind of like the towns in rural areas. So if you have an area of, 2,000, 3,000 people, but they live pretty dense together, then you see district heating systems there as well. So it's a combination of the two, and it really depends on the geography.
And there is one relevant question about the synergies between heat source and heat demand that comes from the other side of the Atlantic. And Jeff Howard asks, where is the best place to look for overview of the spatial density of the European countries in order to compare with density for US states? To me, I would again like provide an answer about thermal atlas, and because there are so many different densities across Europe and across the US. But what is your comment on this?
No, I would say the same. There was an article maybe like 5 or 6 years ago from a guy who tried to do it for the US. I don't remember his name and I don't remember the university. But it was we have a hectare level map of the whole of Europe. Some countries have much more detailed things, but this is also something that we have developed. This is the 4th installment of PETA. So what he did was a bit less detailed. But for North America, I know that Vancouver has a map, I think Toronto has a map. And then there was someone who tried to do the whole of the US, although I don't think it was very detailed. And I'm really sorry, I don't remember any of the names or the universities or the people. But I'd start with PETA and then see if you can find kind of benchmarks.
Yeah, and I think I'll just have the last question now because we have exceeded time. This one comes from Local Lions. And it says, does the research focus on heating and cooling technologies, or does it also consider possible effects of digitalization on district heating or behavior change on energy saving? I think this is a very interesting topic that be considered in the future installments of the Heat of Europe, because as I see, there has been any consideration about the digitalization aspect. What is your comment, Susana, on this?
No, I think it's true. I think it's something that, you know, there's been a lot of development, and it's something that does need to be considered. We have some kind of baseline assumptions on how well both the electricity grid and district heating systems are operated, and that involves that, you know, the best practices in terms of the current use of digitalization happen. But you know, looking at how fast this is developing, it's very well possible that that becomes much better really quick. And you know, that's not something we've been able to bring into this iteration, but would be really important to include in the future.
Well, thank you, Susana, for your answers, and thank you all for your participation. The recording will be soon available on our website and the YouTube channel. And here I would like to say that our next webinar is on the 18th of October, where Susana will be here again, and this time with Wout and Nies from the Joint Research Center, who will talk about the combination of the energy modeling tools and its importance in the energy transition. You can visit our website to get to know more about the Heat Roadmap Europe project and the latest results, and follow us on Twitter to stay updated. We look forward to having you next week again, and thank you for attending. Have a nice afternoon. Thank you, Susana.